Voyager 1, NASA's farthest voyaging rocket, continues its amazing venture through space, flawlessly communicating significant information from the deepest areas of the universe for almost 50 years. This phenomenal space probe has revolutionized our understanding of space. However, as of late, the spacecraft has been communicating disturbing data back to Earth, leaving the entire space industry in shock. Are these troubling signals the result of a technical breakdown, or the activities of extraterrestrials? Join us as we uncover the reality behind these stunning transmissions. Since the beginning of recorded history, researchers have been enthralled by the secrets that lie beyond our heavenly boundaries. This interest prompted the historic launch of the Explorer 1 and Explorer 2 shuttles, among other wonderful space missions. These momentous missions, which had been discussed for quite some time, began with the launch of Explorer 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5th of that same year, Explorer 1 followed suit. These twin probes, each weighing a significant 720 kilograms, comparable to a small vehicle, were propelled into space during a unique alignment of the outer planets. Throughout their staggering odyssey, these courageous voyagers navigated different directions and speeds, leading to a crucial moment on December 15, 1977, when Explorer 1 outpaced its identical twin due to variations in their paths. Since then, Explorer 1 has become a significant asset, providing us with a wealth of information and unraveling space-related secrets. Before we delve into Explorer 1's startling new discovery that stunned the entire space industry, let's explore the exceptional images captured by the rocket during its pivotal Jovian imaging mission. In 1978, Explorer 1 was positioned roughly 265 million kilometers from Earth. From this vantage point, it communicated a stunning number of photos back to Earth. In January 1979, it embarked on an exceptional 100-hour endeavor, capturing a mesmerizing time-lapse film exhibiting 10 rotations of Jupiter. A cornucopia of 3,750 pictures allowed us to observe Jupiter's magnificent dance in vivid detail. In the ensuing months, Explorer 1 wandered through the Jovian moon system, making a striking revelation: the presence of a small ring surrounding Jupiter and 2 new moons, which further expanded our understanding of Jupiter's fascinating domain. To ensure safe passage and prevent a potential impact with Titan, one of Saturn's moons, corrective maneuvers were executed. Explorer 1 continued its celestial journey around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, Dione, and Rhea. With the culmination of the Saturn mission, researchers decided to conclude the Explorer planetary mission, pushing both Explorer 1 and Explorer 2 beyond the bounds of our planetary group, leaping through space at an astonishing rate of 325 million kilometers each year. In January 1990, another chapter began: the Explorer interstellar mission. During this stage, Explorer 1 delivered some of the most famous photos in history, immortalizing the Sun and the majority of the planets. One person who played a vital role in extending the missions beyond their initial objectives was the prominent astronomer Dr. Vasily Sands. As a part of the Explorer mission's imaging team, Dr. Sands ardently advocated for capturing one final set of pictures as a goodbye gift to humanity. Against all odds, his steadfast determination bore fruit on February 14, 1990, when Explorer 1, positioned 6 billion kilometers from the Sun, embarked on a visual excursion well known as the Planetary Group Family Picture. These stunning images, totaling 60, added to the shuttle's remarkable collection of 670 photos. During its encounter with Neptune, Voyager 2 achieved an extraordinary accomplishment by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind ever documented within our local planetary group. As the rocket ventured within 280 miles of Neptune's blue, methane-rich atmosphere, it provided us with remarkable insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed as one of the coldest residents within our planetary group, with surface temperatures plunging to a frigid 391 degrees Fahrenheit. Triton's peculiar features, such as its nitrogen gas-spewing ice volcanoes that pushed icy particles 5 miles into its nebulous atmosphere, also captivated our imagination. These exceptional discoveries expanded our comprehension of the vast variety and complexity of celestial objects residing in the farthest reaches of our local planetary group. Don't go anywhere. The Explorer-1 rocket has recently made one of its most frightening discoveries. But first, let's find out what it has achieved in the last 45 years. The accomplishments of the Explorer twin tests have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these remote worlds. These moons, once believed to be dormant and heavily scarred like our own moon, turned out to be teeming with geological activity. Explorer 2, in particular, achieved several exceptional feats during its journey. It made history in 1986 by becoming the first shuttle to fly by Uranus. Just 3 years later, it achieved another remarkable feat with a flyby of Neptune. Up to the present day, it remains the sole rocket to have ventured on such a path. As the Explorer rockets continued their journey, NASA implemented various measures to extend their operational lifespan. Over recent years, unnecessary parts and heaters have been deactivated to conserve energy, ensuring that these courageous explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this remarkable project from the very beginning, the culmination of the Explorer missions is both a moment of pride and a tinge of melancholy. Their steadfast dedication and passionate efforts have far surpassed their initial expectations. The wealth of data returned by the explorers has provided valuable insights, fueled numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Explorer 1 and Explorer 2 were no ordinary space probes. They were meticulously designed as stable platforms with a rotation rate over 15 times slower than the hour hand of a clock. This design decision minimized visual blurring as the spacecraft captured images and data while journeying through the infinity of space. Even before their encounters with the outer planets, their impressive imaging abilities began to astonish scientists and the public alike. The spacecraft began transmitting images of Jupiter before reaching the gas giant. These early images, displaying the swirling clouds and iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon, Io, that truly took the spotlight. Io, somewhat larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments identified peculiar signals from Io, which were confirmed by the distinctive images they captured. Towering volcanic plumes and a surface scarred by volcanic eruptions were revealed. One of Io's most prominent volcanoes erupted with a force 10 times greater than Mount St. Helens, covering an area almost the size of France. While the spacecraft's cameras were ultimately shut down to conserve power and memory before their journey into interstellar space, it is noteworthy that the photographs they captured did not include Mercury and Mars for various reasons. Aside from the Explorer 1 and Explorer 2 interstellar probes, NASA has also operated other prominent spacecraft like Voyager 10, Voyager 11, and New Horizons. Explorer 1 passed by Voyager 10 on February 17, 1998, marking the occasion when Voyager 10 became the most distant spacecraft. Explorer 1 continued its solitary journey for an additional 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes in sight to witness, NASA didn't publicly announce this remarkable achievement until 2013. What procedures ensured the success of the Explorer missions? One method stood out as particularly brilliant: gravity assist maneuvers. These maneuvers played an essential role in propelling Explorer 1 and Explorer 2 on their audacious mission to explore the outer reaches of our solar system. To reach these distant destinations and gather valuable data, the spacecraft needed more than just their own propulsion systems. They needed a boost, and gravity assists provided just that. Imagine the two fearless rockets, Voyager 1 and Voyager 2, embarking on their grand tour through the local planetary group. Instead of relying solely on their motors, they engaged in a celestial dance with some of our local planet's heavyweights. These planets formed groups that performed an incredible dance, leveraging the vast gravitational pull of these giants to slingshot themselves on their way. This method allowed them to conserve valuable fuel and gain the necessary speed to visit various destinations. Delving into the fundamentals of gravity assist, also known as a gravitational slingshot, we see that the idea behind this maneuver is to transfer some of a planet's energy to the spacecraft as it passes by. Imagine Explorer 1 approaching Jupiter, a massive gas giant with a matching gravitational pull. With meticulous precision, Explorer 1 swung by Jupiter at the perfect angle and speed. Jupiter's gravity tugged at the spacecraft, accelerating it to a higher velocity and providing it with a significant boost. Performing a gravity assist maneuver requires exceptional precision. If Explorer 1 had approached Jupiter at the wrong angle or speed, the slingshot might have resulted in a disastrous deviation from its intended course. The level of accuracy required is daunting. However, the brilliant minds behind these missions successfully executed these gravity assists multiple times, propelling the Explorer spacecraft on an astonishing journey through the local planetary group. Explorer 2, for example, utilized gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were of vital importance in making the Grand Tour possible. The Explorer missions owe much of their success to these gravity assist maneuvers. Explorer 1 continued to reach interstellar space, with Explorer 2 quickly following suit, all thanks to the accuracy of these maneuvers. The concept behind gravity assist is simple, but the execution is extremely complex. Explorer 2's Grand Tour required a level of precision where missing any of these slingshots could have resulted in a failed mission. However, the dedicated individuals behind these missions were determined and steadfast in their pursuit of knowledge. While gravity assist played a significant role in exploring the universe, another critical component ensured the success of the Explorer missions. The Deep Space Network, DSN, often considered the interstellar phone line that kept us connected to our brave Explorer probes as they ventured into the great unknown. The DSN, though less flashy than a spacecraft, is equally indispensable. The Deep Space Network is a system of massive radio antennas strategically positioned around the world, including locations in California, Spain, and Australia. These gigantic dishes, ranging from 26 to an incredible 70 meters in diameter, act as vast amplifiers, facilitating communication with spacecraft traveling beyond our planet. The Explorer probes, equipped with cameras, sensors, and instruments, served as our eyes and ears in the vastness of space. To make sense of the data they sent and to provide them with new instructions, a robust communication system was essential. That's where the DSN came into play. Imagine Voyager 1 on its way to the outer reaches of the solar system, sending a message back to Earth as a faint signal traveling at the speed of light. As it traverses the infinite expanse, the signal weakens. By the time it reaches Earth, it's a whisper. However, the colossal radio antennas of the DSN are poised to capture that whisper. They lock onto Voyager's weak signal, working on it and transforming it into data that scientists can analyze. But the DSN doesn't just receive signals. It also sends commands. The Explorer missions are dynamic endeavors, requiring scientists and engineers to adjust trajectories, redirect the spacecraft, or tweak instruments. The commands are sent via the DSN, which transmits them into space to reach Voyager and guide it. It operates as a two-way conversation between Earth and the farthest human-made objects in the universe. One remarkable aspect of the DSN is its tireless operation. It works tirelessly 24/7, listening for those distant signals. It's like an unblinking eye on the universe, ensuring that we stay connected to our space probes even when they are billions of miles away. The Explorer mission stands as a testament to the power of collaboration and innovation. While the spacecraft embarked on their grand journeys, the DSN ensured they were never truly alone. It bridged the gap between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. Did Explorer 1 experience a breakdown, or were aliens involved? Throughout its remarkable 45-year journey in space, the Voyager 1 space probe has remained healthy, diligently performing its mission. However, in recent times, experts have noticed some abnormalities in performance that have sparked interest and curiosity. Explorer 1 is currently sending peculiar signals back to Earth, creating the impression that it is uncertain about its exact location coordinates. What makes this discovery even more perplexing is that the initial data received from Explorer 1 were incomprehensible and unimaginable, leaving NASA scientists puzzled. Upon examination, scientists found that the culprit behind the distorted data was the Attitude Articulation and Control System, AACS. This embedded equipment is responsible for measuring, reporting, and adjusting the spacecraft's position in space. It has an antenna directed towards Earth, enabling it to send data back home. The malfunction had occurred when the software abruptly changed to sending its telemetry data through a faulty embedded computer that had been dormant for years. NASA engineers were able to correct this anomaly by instructing the spacecraft to resume sending data through the correct computer. Thus, uncorrupted data from Explorer 1 is once again reaching NASA. However, the question that remains unanswered is why the spacecraft switched to the malfunctioning computer in the first place. While NASA scientists have put forward a hypothesis that a faulty command from another onboard computer might have triggered the strange behavior, they have yet to pinpoint the exact cause. To get to the bottom of this mystery, Susan Dodd, the project manager for the interstellar mission, stated that they intend to conduct a thorough memory readout of the spacecraft and fully analyze its operations. This in-depth examination aims to examine the issue that led to the telemetry problem. It is noteworthy that despite the erratic data transmission, the spacecraft itself seems to be functioning properly. None of the spacecraft's fault protection systems have been triggered. As such, Explorer 1 has not been forced into safe mode, and its signal remains strong. A possible factor contributing to this inconsistency is the harsh environment of space. Cosmic radiation and extreme temperature fluctuations can pose challenges to the operation of a spacecraft like Explorer 1. Cosmic radiation consists of high-energy particles originating from distant stars and galaxies. These particles can penetrate spacecraft structures, causing electrical disturbances, data signal distortions, memory errors, and data corruption. Additionally, temperatures in the vastness of space can drop to bone-chilling levels or soar to scorching highs, putting immense stress on the spacecraft's components. Despite the rigorous testing and meticulous engineering that went into designing Explorer 1 to withstand these conditions, the harsh realities of space can still take a toll over time. Another intriguing possibility that has captured the imagination of some is the idea of extraterrestrial interference. Could Explorer 1's anomalous behavior be attributed to the actions of intelligent beings from beyond our solar system? While this idea may seem more akin to science fiction than reality, it's not entirely outside the realm of possibility. The vastness of space and the countless exoplanets it harbors leave room for speculation about civilizations far more advanced than our own. However, before jumping to conclusions of alien intervention, scientists are diligently examining every aspect of Explorer 1's irregular behavior. Whether the spacecraft's anomaly is due to a technical glitch, cosmic radiation, or something else entirely remains to be seen. But one thing is certain. The mysteries of space continue to intrigue and inspire us, driving our relentless quest for knowledge and understanding of the cosmos.